Hello, this is section 3.1 for Calc AB, and today we're going to be talking about the extrema on an interval. So first we'll start off with what is extrema, what the definition of extrema, and that is f of c is the minimum of f on an interval I, where fc is less than or equal to f of x for all x in that interval. So basically it's the lowest point in the interval. And then the maximum is the opposite, so it's the highest. Notice it's f of c is greater than or equal to f of x for that interval x and I, right? So the min and max of a function on an interval are extreme values or extrema of the function on the interval. The min and max of the function on an interval are also called the absolute min and absolute max. So this is really important. If it ever just says max or min, they're referring to absolute max or min. And we'll get into a different concept here soon where we'll put a different word in front of min or max and it'll mean something different. So whenever you see absolute max or min or just max and min by itself, you're going to assume it's the highest number or the lowest number in the interval. Okay, so here's some visuals. And notice it's in a closed interval. So you are going to consider the endpoints, and that's very important with the extrema. You have to consider the endpoints and then any point within the interval as potential max or mins. So on this closed interval, the endpoint's a max and the point actually within the interval is your minimum. Now in this case, you can see that the endpoint has an open circle. So even though you've got all of these values leading up to that open circle, you can't pick a number. So at 2, we have the value of 5, but it's not defined. So you'll always be able to pick it. You could pick something maybe at 2 or 1.999. Well, then I'll say, well, what about the point 1.99999? And there, I can always find something closer to that open circle. So there's actually not a maximum on this one, but there is a minimum here. And then for this one, here's an example of you don't have a minimum, but you do have a maximum. So there's a lot of things to consider when you're finding and justifying your absolute max and mins. Okay, so here's your extreme value theorem. If f is continuous on a closed interval, then f has both a min and a max on the interval. And you might say, what? We just looked at some where we were on a closed interval. Okay, but remember, it says it has to be continuous on a closed interval. And when that happened, notice we're continuous on a closed interval. Yes, we had both a max and a min. Whereas these two were not continuous on a closed interval necessarily. This one's continuous, but it's on an open interval. All right, but if you meet that condition where f is continuous on a closed interval, including the endpoints, then you are guaranteed a max and a min. Now, when I first read that, when I started teaching Calc AB, I said, what about the horizontal line? Well, that means all points are both max and mins, meaning you can have more than one max and more than one min. Okay, now, relative extrema. So if there is an open interval containing C on which f of c is a maximum, then f of c is called a relative max of f, and then vice versa, relative min. Now, this is going to be within an interval, so this is not going to include the endpoints. You're always going to be, there's going to be numbers around it, so you can really see within that local, and oftentimes that's what that local is coming from. And the local region, is that the highest that you go, or in that local region, is that the lowest that you go. So never on the endpoints are we going to talk about relative max and mins. Okay, so you can see within this local region, that's a relative max. Here it's a relative min. You might hear some teachers call it hills and valleys, but here's a relative max, a relative, and in this case, you have it on a closed interval. So we've got we're guaranteed, remember, an absolute max and min. So we have a relative max here. This is both a relative min and an absolute minimum. And then up here, this is just an absolute max. And this actually isn't considered anything. So, all right, now critical numbers. This is where your interesting things are happening on the graph. So let f be defined at c if the derivative at c equals 0, or if f is not differentiable at c, then c is a critical number of f. So it's important that you notice that f has to be defined at c. So that's very, very important. Notice that's the very first thing they state. If f is defined at c and then it meets these two conditions, one or the other, then you have a critical number. So again, it's where your interesting things happen on your graph. So here's an example of the derivative not existing. Remember, the slopes are different from the left and the right. And then in this case, your derivative is equal to 0. But these are examples of critical points. And then this is really awesome. Relative extrema occur only at critical points. So if you start off by finding all the critical points, then you can go back and start labeling those critical points, determining if they happen to be a relative max or relative min. And they could be neither, but at least you'll know where all the interesting places happen on your graph. Okay, so here are some examples of your relative max and mins, and you'll notice where you have your relative max and min, slope of the tangent line is 0, making it critical numbers. A and B are critical numbers. Here's again, slope is 0, that's a relative max. Here the slope is not defined, or slope, excuse me, the derivative is not defined because the slopes are different from left to right, and notice that happens to be a relative max. Now that's not always going to be true, but that's where the interesting things will happen. Okay, so here I go into some examples. Find any critical numbers, so do the derivative, set it equal to 0. Especially for a nice polynomial function. There aren't going to be any sharp turns or asymptotes or anything weird happening, but so you'll just want to set the derivative equal to 0. Okay, same thing on the next one. So set the derivative equal to 0 and solve from there. And notice it's within this closed interval. Now, guys, these problems will easily be worth at least 3 points. And this step right here, setting that derivative equal to 0 is huge. That I will definitely, that'll be at least worth 1 point. I will want to see that very important step in your work. So make sure you always show me that you set your derivative equal to 0 when you're finding critical numbers. Very important right there. Okay, notice I showed that step here as well. All right, so guidelines for finding extrema on a closed interval. Now notice, it just says extrema. That means you're talking about absolute max and mins, not relative max and mins. Relative max and mins are within an interval. This is talking about what is the highest and what is the lowest your function goes on a closed interval. And remember, this includes endpoints, where relative extrema is within the interval and will not include endpoints. Okay, so it says find the critical numbers. So that's that really important step of setting your derivative equal to 0. Evaluate f at each critical number in A and B. We call this the candidates test. So that's what's here. Evaluate f at each endpoint. And that 2 and 3 are kind of the same step. And then the least of the values is the min, the greatest is the max. So here's an example. Find the derivative, set it equal to 0 to get your critical numbers. And we only care about the critical numbers that fall within our interval over here. So we end up throwing out negative 2, excuse me. So then I want you to see I'm going to look for this in your work. Did you do the candidates test? Did you check the endpoints? And did you check any critical numbers that fall within this interval? Because remember, critical numbers are where interesting things are happening. And at a critical number is where you could have an absolute max or an absolute min. So we're checking this critical number at 2. And sure enough, when you plug all these numbers into your function, you can see you have an absolute minimum right here, and here's you have an absolute max because this is the highest. Okay, so set your derivative equal to 0 to find the critical numbers. Create a candidates test. Make sure you check the endpoints and any critical numbers that fall within our range that we care about. Okay, now here's another example where we did the derivative, set it equal to 0, and we notice that 5 comes from the denominator. It's not defined on the original function. So in this case, remember that was the very first step and with critical numbers is it has to be defined on the original function. So in this case, we don't have any critical numbers. When we set the derivative equal to 0, there's no critical numbers. And that's okay. So that means when you go to do your candidates test, you just have to check the endpoints. So make sure your critical numbers are only where the function is defined. Okay. And then here's one where we do the derivative. We had to use the product rule here. Remember, first times derivative of the second plus second times derivative of the first. Then factor out what you can. So you can set it equal to 0 and you get all these critical numbers. Only use the ones that fall within our range. So we set up the candidates test, endpoints, and then any critical numbers in the middle. Okay? So remember, easily probably 5 or 6 points on this type of problem. Set the derivative equal to 0, get your critical numbers, create your candidates test, and make sure you label your answers. This candidates test is so important because that's your justification to your answer. So that's why this is so important. Okay. All right, now here at the end, I put some graphing calculator practice. So we will do this in class, and if I need to, I'll look through it and decide if I want to make another video having to do with graphing calculators. But just making sure that you can use the trace feature, making sure you know how to use the calculator to get the max and min, and go on your calculator, graph it. Remember, go to the menu part of your calculator and practice. Okay, so all right, really important concepts in here. Critical numbers are where interesting things are happening on your graph. Set the derivative equal to 0 and make sure it's defined on the original function. If it ever just says max or min, you automatically need to think absolute max or min, and meaning you're going to check your endpoints and pick the biggest numbers. If it says relative max or min, that's always within the intervals, never on the endpoints. Okay, so all right, please make sure you do your homework and email me if you have any questions.